Doebner modification is the organic named reaction we are going to discuss in this session. The detailed insights regarding this Doebner modification is discussed over here. Earlier we already gone through various sessions based on organic named reactions and also the segments of organic chemistry, normal chemistry, material chemistry, engineering chemistry, environmental science, competitive examination perspective, CSAR net previous year question papers, JEE in the NEET examination previous question papers, and also 10th class chemistry. So many kind of fields we already gone through, and all the series of sessions, various playlists available at the channel World of Conceptual and Competitive Chemistry. If you subscribe the channel and watch regularly, definitely you will get the success in your academics, research, and also competitive examination what you are actually aspiring for, even for the 10th class, graduation, post-graduation, research, PhD scholars, scientists, academicians, and for all these kind of one, the session is very much helpful. So here the Doebner modification, what the content we are discussing now is taken from the textbook of organic named reactions, which is written by Dr. Kavitha Kotthireddy, Kota. Let me introduce this Doebner modification process. The Doebner modification is a non-integral condensation process only. It is light variation only, used for synthesizing alpha beta unsaturated carboxylic acids. The final product could be alpha beta unsaturated carboxylic acid manufacturing. So we can react aldehyde with the malonic acid. Aldehyde, upon reacting with malonic acid in the presence of base is going to be reacted over there. So base is going to react with this one, so that your Doebner modification giving rise to alpha beta unsaturated carboxylic acid as the final product. Right. So here general reaction is aldehyde upon reacting with dicarboxylic acid in this manner. So under basic conditions, there is a provision for alpha beta unsaturated carboxylic acid as the final product. This is called Doebner modification. And here you can notice the kind of dicarboxylic acid taken over here, malonic acid in specific, and here is the aldehydic compound was taken. The reaction facilitated by base, that's the reason why I am adding pyridine as a catalyst. So here the temperature, slight heating is required over there, that's the reason why the reaction is proceeded, and moreover here the formation of alpha beta unsaturated carboxylic acid as the final product. Here is the reaction synchronization. You clearly understand how the reaction taken over there. Aldehyde is supposed to be treated with dicarboxylic acid. Simply malonic acid was taken over there. This carbon atom is active methylene, right? So in between two electron withdrawing functionalities, whichever carbon that is experiencing active methylene, that is having more acidic protons. So immediately go for the reaction with this carbonylic carbon atom. Subsequently dehydration, condensation taken place by dehydration process, so that here the double bond origination. So whenever double bond located over there, you are supposed to remove one of the carboxylic acid by decarboxylation, so that carbon dioxide is removed as a byproduct. The reaction is, in order to generate first carbon ion, we need to go for the base, right? Being active methylene compound is more susceptible to lose the proton, so here base will facilitate that reaction. So that carbene, whichever generated, will go for the nucleophilic addition with the carbonylic carbon, and subsequent there is alpha beta unsaturated carboxylic acid product formation is possible. This is the way the orientation matters for this product formation by Doebner modification reaction. In order to understand the reaction in the well manner, there is a mechanism located over there. First of all, we have to take this dicarboxylic acid with the active methylene carbon atom in between. Always active methylene carbon, which is located in between two electron withdrawing groups, having susceptibility to release the H positive toward the base. Whatever base, mild base is more sufficient, need not to go for the stronger one, being it is very easy to release the protons, right? That's the reason why mild base is sufficient to remove that one. So that the ultimate requirement is the generation of carbene. Whichever carbene generated, now go for the nucleophilic addition at the carbonylic aldehydic functionality carbon atom. So pi bonded electrons are migrating toward the oxygen. Whenever pi bond is migrating toward the oxygen atom, there will be a new carbon to carbon bond formation is possible. That newly formed carbon to carbon bond is located in between these two, and here the carbon experiencing hydroxyl functionality, and here the pH group is present on this benzene ring. This is the way kind of new nucleophilic addition carried in between. Later on, we are supposed to remove this carboxylic acid, being adjacent carboxylic acids are not that favorable, and immediately it will go, being we are providing the higher temperature conditions. That's the reason why, being this decarboxylation is facilitated by heating conditions, because we are rising slight rising in the temperature taken during the reaction process. That's why decarboxylation is a familiar thing taken over, and the pi bonded electrons whichever located are moving toward this side in order to make a new carbon pi bond. Subsequently, this hydroxyl group is totally departed by protonation followed by dehydration. So this is the way decarboxylation, dehydration taken, giving rise to alpha beta unsaturated carboxylic acid. The entire mechanism is represented in the well manner. Hopefully it is giving the clear information regarding the Doebner modification named reaction. The reactants taken are one will be aromatic aldehydic compound, most probably benzaldehyde taken. It is the familiar compound for this Doebner modification. Malonic acid, either active methylene compound, both are the reactants. Catalyst will be mild base, either pyridine or piperidine taken as a basic condition. Product ultimately cinnamic acid derivative like alpha beta unsaturated carboxylic acid could be the ultimate product over there. Here is the kind of complicated molecule origination by simple Doebner modification process. You are going to proceed. Here is the aldehyde, which is the requisite functionality for this Doebner modification. Whenever this aldehyde is supposed to be reacted with this amine, what is the process? There is a skip base formation taken by condensation. Amine having more tendency to react with carbonyl, so that here is the double bond location. After getting this imine, this is called imine functionality, there is a alpha keto carboxylic acid reaction with this one. Whenever this is the reactant added, this reactant is going to build a pyridine ring over there. Ultimately there is a formation of quinoline, and the side chain whichever present, that remains as such. Furans ring remains as such. There is a formation of the molecule which is called a quinoline. So this is also the kind of Doebner modification example. Here is the two pyridine molecules are reacted in the presence of thionyl chloride. There is N alkylation taking place. So upon the nitrogen atom, the entire pyridine ring is reacted once again. N-pyridinium chloride is the chemical name of the compound what we got. If you are going to react with the nucleophile, what happens? The entire molecule will go for the reaction with the nucleophile at the position number 4. Here is the another example pertaining with Doebner modification process. I am taking aniline and treated with alpha keto carboxylic acid, just like this. Alpha keto carboxylic acid, just like this, the reaction is taking place. And one more molecule requisite, one will be aldehyde. First of all, aldehyde is going to react with this aniline. There is a formation of imine. Later on, it will be treated with that one in order to make up this quinoline molecule. Just now we gone through the same reaction, but a side chain Furans ring is there. But here anyway we got synthesized this quinoline molecule within this, and wherever carboxylic acid, that may not taken part of this reaction, rather this alpha keto group is more susceptible for the reaction in this process and taken part of this quinoline fabrication. If you want to observe the applications of Doebner modification, cinnamic acid derivative synthesis is the ultimate product formation over there. Whatever products we got having that fragrance activity, though, so that they are working like perfumes in the industrial process, and they are giving the flavors to the taste, so that they are also like flavoring agents in the food industry. Even pharmaceutical applications also more significant for these Doebner modification products what we are obtaining, and intermediates in the styrene and coumarin synthesis. In order to synthesize coumarins and styrenes, you better choose Doebner modification process. So this is the way multiple applications are pertaining with this Doebner modification, so that it is a significant reaction in the field of synthetic organic chemistry. So these are the kind of perfumes you can notice they are having fragrance tendency because of this. Perfumery manufacturing is taken as application for this Doebner modification reaction. Here another named reaction you can notice Edmond degradation. In the next session we are going to deal with this Edmond degradation process. Meanwhile we are going to conclude this. Hopefully this is an informative session, got the clear cut information regarding the named reaction Doebner modification. You can watch the entire session without any interruption, so that you will get the sound knowledge about this reaction and their application purview as well. So thank you very much for your patient listening. Thank you one and all. Watch regularly and share with your friends, so that you will get the new content every day. Thank you very much. Signing off, Dr. Kavitha Kotthireddy, Kota.